In this lecture, I will be starting a new topic that is ergonomics. So, this subject is or this topic is extremely useful in developing and designing the systems, machines, equipments, components which are used by the human being. Uh, so that these can be effectively used with the minimum fatigue and very efficiently. So, what are the various basic principles, the concepts, and the points which are to be kept in mind, or the knowledge which is needed in coming up with such kind of the products and the components and the systems which can be efficiently used by the human being? Uh, we will be talking in detail in this subject about those principles and the broad areas which are used for designing the components for use by human being. So if we see the term ergonomics, so this word is basically composed of the two words like ergos, which means, these are the two Greek words basically. Ergos means work, and nomos means the rules or the law. So, work laws is the typical literal meaning. So, the principles or the broad fundamentals which are useful in designing the systems so that the work by the human being can be done very efficiently using those systems. And this combined word ergonomics, from the ergos and nomos, was given by the British scientists in 1949. Okay, so it combines the two Greek words basically, ergos and nomos. So if we have to understand what ergonomics is, it is basically the scientific study which involves the man, machine, and the environment in which work is being done. So ergonomics is basically scientific study of the relationship between the person or the man or woman, the machine which is being used by the human being, and the environment in which work is being done. Okay, so relationship between the person, machine, and the environment in which the work is being done, all that is included and the covered in the ergonomics. So it is basically the scientific study relating the showing the relationship between the human being which is using the machines in a particular environment. Okay, this is also termed as, means ergonomics is also termed as human engineering. There are different other common words related with, like one is also known as, ergonomics is also known as hybrid science. The reason behind giving these the involving the machines and the systems for engineering and the human, these two things are combined, where work is being done by the human being on the machines in a particular environment. Hybrid science is also used because it to understand this domain, or to study, to make the scientific study of the relationship between the persons or human being, machines and man, it requires the knowledge and experience of the various domains, which involves like anatomy. Then it also involves the use of physiology. It also involves the psychology and the engineering systems or the machines. Okay, so these are the four different experience or knowledge related with these four different domains is needed to make the reasonably good scientific studies related with the human being using the machines in a particular environment, so that these can be developed in such a way that it forms or constitutes an efficient system wherein the required output is achieved with the minimum inputs in form of efforts, fatigue, resources, etc. Okay, so since it involves the knowledge of these four different domains, that is why it is also called hybrid science. Okay, now we'll talk a little bit about these four different domains related with the ergonomics. So how it has involved, means how this broad area has evolved. If you have to see this, so initially what was the approach in the initial stages, like fitting human being, a man or woman, to the machines. How? Like trying to give the enough expertise, training, and whatever the things which are needed uh, to train or to give the skills to the human beings, so that these can be used efficiently by these can so the human being can efficiently use the machines. So basically imparting the required the training and skill to the human being, so that these can effectively use, these human being can effectively use the machines. This was the initial stage approach. Subsequently it was just reverse, like let us come out with those foolproof systems, means come out with such kind of the machines, so that these are easiest to use by human being. So the approach was completely different, like fitting machines to the human being. Okay, so it was just opposite, like coming out with such kind of the easy to use systems and the machines, so that the workers or the human being can use them very easily. And currently it involves the fitting of the man and machine together. So in larger interest of both, coming out such kind of the systems, so that both the human being and the machines are well integrated, or that designed in such a way that the human being can use these machines very efficiently and effectively. So the gradually there has been a continuous shift in the way by which the systems have been designed and evolved for use by the human being. Okay, so like starting from whatever systems, components, machines which are being used by the human being, these must be designed in such a way that human being can use them with the minimum fatigue, with the minimum effort, and without causing anxiety, without causing much disturbance to the human body. Okay, so what are the different things which should be kept in mind while designing the workplaces, designing the engineering systems, designing the work environment in which the work is to be done? So what are the different things should be kept in mind when such kind of the things or the systems components are designed for human being? Like starting from the designing of pen, bicycles, chairs, bed, car seats, cars, anything, whatever you see that is designed and made for use by the human being, and if its design is such that it is difficult to use, means it is not well ergonomically designed, because it poses difficulties in use of such kind of the systems. So now here the point is, what are the different things should be kept in mind while designing such kind of the systems, and what is the importance of these four domains which are related with the ergonomics. Okay, so ergonomics involving like anatomy, basically this is anthropological aspects. Okay, anthropology. So here we can also like anthropometry. Okay, so anthro is about the human being and pometry is about the measurement. Okay, so this you can say the broadly the part of the anatomy, wherein we are primarily interested in the anthropometric aspects for coming out with the designs which can be efficiently and effectively used by the human being. Okay, so it involves the use of the various measurements associated with the target users, target population for whom the systems are being designed. For example, the bench in the park is designed for none. Neither kids can use that efficiently nor adults. Similarly, the things which are in public places are for entire range of the population, irrespective of their anthropometric aspects. Means those will be causing minimum discomfort to all. Means it will neither be best for any of the category of the users. Okay, but the moment we identify the category of the users, the population for whom the system is being designed, we need to use the anthropometric data related with that population, related with that group of the population. Okay, so like something to be used by the army personnel where height is say more than 5.8 feet, so the kind of the systems and components used by them will be completely different than the another user group, like say the chairs and tables and the things to be used by the KG students or the middle class students, where they are so the where the height and anthropometric dimensions are completely different than the adults. Okay, so as per the user group for whom the a particular component is being designed, anthropometric aspects should be kept in mind. So what it involves? Anthropometry is basically about it is the study of so anthropometry is about the study of the variation in the human characteristic, human body dimensions, such as the height, weight, the reach of, that's the arm length, which reach can be significantly different from arm length itself, and likewise like depending upon the component, head length, head width, and then height, eye height, nose height, head height, stature, then knuckle height. So there can be the different aspects related with the anthropometry, which can be used for designing the different components, different systems. Say the bed height will be governed by some other parameters, while the wristwatch dimensions will be governed by the different dimensions. The spectacles and the goggles will be designed using the different dimensions. So these whatever systems to be used by the human being, those will be designed considering some kind of the dimensions of the human being, or target user of the human being. Okay, so these obviously these, for each user group there will be a lot of variation. Like say if something is being designed for adult, okay, so adults, say height or the weight, or likewise other body dimensions, these will be changing significantly. So to how to arrive at a particular dimension for which a system should be designed. Okay, so what we do basically, whatever the body dimension is of our target, whatever body dimension is to be used for the design purpose, that is chosen first, and then average value of the target users is identified. So what we do, identify that the body dimension characteristic which is to be used for the design first. This identification of this characteristic is important, and then get the data of that characteristic for the users. Okay, and then from that data determine what is the average value and what is the range of that data. Okay, and these are used subsequently for designing the components for that particular user group. Okay, so if we know the body dimensions or the relevant anthropometric dimensions of the human being who will be using a particular system, once we are aware of the average that characteristic or the range of that characteristic which is relevant for design of a particular component or particular system to be used by human being, this is useful in number of ways. So anthropometric dimensions of the human being for a particular user group, once if that data is available with us, it can be used, say for example, determining the boundaries of the workplace, where what will be placed and how far you can place the things. Okay, but boundaries of the workplace. Okay, so where the brakes will be placed, where the steering will be placed, where hand brakes will be placed, where gears will be located, all these tools and things which are to be used by human being. Okay, so where what will be placed, uh, for use during the work or during the application of a particular system that is identified based on the anthropometric data related with the user group. Okay, now you will see the another one is, just for an example, the height and the shape of like chair, seats, work tables, etc. That is defined, so that is identified based on this anthropometric dimensions. Okay, anthropometric data. There is a very wide range of the parameters which are used as anthropometric data. So I'll be showing one of the diagrams just to make it clear. This anthropometric data is also used in designing the handles, levers, wheels, so that these are effectively used, or these are easy to use by the human being. Like we have to see what is the maximum force that can be applied. Okay, like handle of a particular thing, you must have seen the screwdriver of the different sizes. So if the very heavy force is to be applied for use of the screwdriver, then the handle grip will be large in size. If very light force, just like in testers, electric testers, if very light force is to be used during the use, then very small diameter the handles and the levers can be used. So depending upon the kind of force to be applied during the use, the handles, levers, wheels, and etc. can be designed such that the human being can use them very efficiently. Okay, now we have to see how this anthropometric data is generated. So as far as the anthropometry is concerned, there are two ways of taking the dimensions. One is called structural body dimensions. Anthropometric data is generated in two ways. One is structural body dimensions, and the second is the functional body dimensions. So when the dimensional measurements of the body parts is taken in static and standard position, like when the tailor is taking the dimensions of the different body parts for stitching the clothes, he'll be asking you to stand in a particular position, and then he will be taking the measurements of arm length or the leg length, like that. So those dimensions which are taken when the body is in a static position, in particular standard position, those body dimensions are called the structural body dimensions. So say chain length for wrist watches. Okay, then you can say the foot. You can say the footwears are also designed using the structural body dimensions. Spectacles and the goggles are also designed using the structural body dimensions. So because these dimensions will not be changing when the person is doing any work. So there are certain dimensions which will remain fixed and will not change. Okay, but there are many other dimensions whose value can change. So what we say as far as the functional body dimension is concerned, most of the time human being during the work, the body parts are moving. Okay, so when the different body parts are moving at that time, what is the maximum dimensional aspects related with the particular body member? Say for example, arm reach of the hand may not be equal to the arm length, but it may be influenced by your the shoulder movement and the bending forward or backward movement. So when the certain body parts are moving under those conditions, what are the maximum functional dimensions related with the body? Those are used for designing the systems during the use. Uh, so hand brakes, the levers, and the brakes in cars. So there can be the number of the components which are designed, or the design of those components which considers the body dimensions when the different body parts are moving. So not their body parts are not in static position. Okay, so so there are two ways of determining the anthropometric aspect. One is structural body dimension and another is functional body dimension, and in both the cases, with the change of person, like if there is a population of particular category, so for each body dimensions average and the range has to be identified, so that the design is developed in such a way that it is able to cover most of the audience or the target group, if not all. So as far as the coverage is concerned, say height distribution is like this. Okay, say 5.9 and 5.5 and 5.1. Okay, so it is possible like something is designed considering this 5.5. Okay, so it is possible that it can be used by a percentage, the people who are having the certain height range. So as I have said, whenever if something has to be designed, then we'll be identifying the suitable structural or functional body dimensions, and then its average value and the range will be identified, and we'll be seeing what will be the dimension for which a particular component is designed. Say it is 5, average value is 5.5, so it will be designed for 5.5, and that will allow the users with little greater height and users with a little lesser height. So if there is a possibility that you may have the people of the 8 feet also, you may have the people of the 2 feet also, but it may not be feasible to come out with the design of the components which will fit for, or which will be suitable for the entire range of the population. So what we do, basically we cover the percentile of 5 to 95 percentile of the population, having the body dimensions in range of 5 to 95 percentile. That is how it is designed, so that it is more economically justified. If we go for covering the entire 100% range, then the systems may be uneconomical and it may not be very justified. So in that case, for those very awkward the body dimensions, the customized components are designed and developed, but that is a different thing. Mostly the things are designed in such a way that they are efficiently used, they are cost effective, and they serves the purpose to most of the population, if not all. Okay, so for that, say 95 to 95 percentile of the population is covered. So the choice of the body dimensions is done for the design purpose in this way. So I will talk of the approaches which are used for designing the different components later. There are three approaches: designed for extremes, designed for averages, and designed for adjustable range. So about those approaches I will be talking a little later. This is about the anthropometric aspect, which talks about the variations in the different body dimensions, and choice of the suitable body dimensions as per the component for which it is to be used, or the relevant selection of the suitable relevant body dimensions in design of a component or design of system which is to be used by human being, then determining its average and the range. So this suitable choice of the anthropometric aspects from the structural or the functional body dimensions can be done. Let me show you the stature, that's maximum height, and the posture in a standing, Frankfurt, and sitting positions, arm span, head length, and head breadth. Okay, and other body dimensions like ear to head height, nasal height, nasal breadth, and these are the indexes. These are different indexes, and cranial capacity. So these are, so as per the need we can choose the suitable body dimensions. That is the simple point. Okay. So here then coming to the physiology, so that's another point actually. This is again the anthropometric aspect only. Let me talk a little bit about this. So here if you see that how these dimensions are taken, like from this reference ground level to this level, this is indicating the stretcher. Okay, and from the ground to this, this is the eye height, then the shoulder height, and then the chest depth is for this dimension, elbow height from the reference ground level, knuckle height, like this. So for the different adults, the body dimensions have been identified. Say this is the anthropometric data. This is anthropometric data. Okay. So what it talks of, like what if the lower body dimension and the lower limit and the higher limit. Okay. So for stature height for male, say 63.7 inches. This is the lower side body dimension. As I said, if we talk of the upper and the lower limit of the population who is to be included in the design, then how it is to be done. So what we do basically, like say this is the percentile. Okay, this is percentile. And here the characteristic, that particular characteristic, which it is height or any of these parameters. So what we do basically, this goes in like this, the trend goes in like this. Okay, so here if you see starting from, like say, 0 percentile to the 100 percentile. So the characteristic may range. This is for the maximum and this is for the minimum value. So this range may be too wide actually for any design, and it may not be cost effective. So average is, say, somewhere here. So considering this design can be made, this average design can be made, which will be able to accommodate most of the population. But if some kind of the range has to be given so that it accommodates or it fits reasonably good to those with the lower or the higher body dimensions, then even then we don't cover the 100% range. like say we'll choose 5% on the lower side, okay, and 95% on the higher side, okay. So there are many examples related with this, and this is 95, sorry, 5 percentile. So the higher dimension and the lower dimension, this is how the higher dimension, higher possible dimension which can be accommodated, and the lower most possible dimension which can be accommodated. This is how it is defined. If it is just based on the average, then we will be choosing this dimension only, and if it is possible to provide some kind of the adjustable range, then we will be giving this upper range, and this is the lower range, so that users can use. So here is an example, like adjustable height in the chair is of 150 mm, say to cover the 5 to 95% of the people, like adjustable chair in computers, adjustable chair or adjustable seat in bicycles is given of 150 mm adjustable range. But if you have to give it to the 100% of the entire population, right from the 0 to 100% of the population for entire range of the people in adult category, then you may find this range is say 260 mm. So users increase in user is say just 5%, but the change in height or the adjustable range which is to be given is too wide. So it is just 150 for 5 to 95 percentile, and extra 110 for just 10 percentile of the people. So those who are at the extreme ends, they will be increasing the cost disproportionately. You see, so the purpose is not served to the many people, but the cost is getting increased significantly. So what we do here, we make some kind of the compromise, will come out with such kind of the design so that they fit for 95 percentile of the people as far as the upper side is concerned, and the lower side is concerned is 5 percentile of the people, not the 100 percentile of the range is covered. So that is wherein these dimensions come in picture, okay. Yeah, so if you see the stature for male, for 95 fifth percentile, this is 63.7, and for 95 percentile, this is 72.6, okay. So these are the upper and the lower and the higher body dimensions which can be included in the dimension as per our the target of the design for the audience or for the target people. Similarly, for if it is to be designed for women, then this is how the body dimensions come in. Eye height body dimensions like this, right? The shoulder height like this, okay. For elbow height, like I showed in the previous slide, knuckle height. So the different body dimensions for the different the gender, like male and female, and for different percentile of the dimensions which need to be included in the design. These will be used in the design approaches. If it is for average, say 50 percentile of the people is covered, like say in that case the average, this is the dimension to be used. If it is for extremes, design for extremes is to be used, then we'll have to use this 95 and 5 and 95, this entire range of the dimensions to be used. And design, so and for the design for adjustable range also, this 5th to 95 percentile of the range of the body dimension is used. So we'll be talking in detail about these use of these anthropometric data while talking about the design approaches, okay. So likewise, these are the other anthropometric data for 5th, 50th and 95 percentile of the people who are to be covered in design, and accordingly we use the different the body dimensions, okay. So if this data is not available, then the suitable data is developed average values are identified, and then you see what is the range, what is the average, that is calculated, and then you take a decision if the design is to be made for covering the entire 100% population or for a particular target group wherein 5th to the 95% percentile or 5th to 99 percentile of the population will be covered. So this is how it is done. This is how anthropometric data is used. So now I'll be just skip from this. Okay, so this is about anthropometric. That's the first aspect related to the ergonomics. The second aspect related to the ergonomic is the physiology. Okay, so there are three different aspects related with the physiology which are considered in ergonomics. These are like the speed, accuracy, and the force that a body member can apply. So these are individual, specific to the individual body member, like the speed with which finger can be moved or leg can be moved, accuracy with which finger can be moved or leg can be moved, or the force that can be applied by a finger or by the leg. So depending upon the body member to be used in the design for use of the system by human being efficiently, we have to see with what speed, with what accuracy, and what force a body member can apply, so that this is considered in designing the component suitably. For example, if you need to apply very heavy force, okay, then you cannot design a system to be used by fingers. You will be designing a system to be used the body members like the leg or those which are having the body parts having the strong muscles, they can be used in the design for using the functional for operating the system. Okay, so the point here is you will considering the possible use of the body parts in use of a particular system, you will be keeping in mind how much force, how much accuracy, and with what speed the particular body member can be used for applying the force, for applying the motion, for applying the controls during the use of a particular system which is being designed. Okay, so the capability of the body members with regard to speed, accuracy, and force is to be kept in mind so that it is used efficiently when a component is designed based on that. The second aspect related with the physiology is the stamina, human stamina. Human stamina is about the ability of the human being to do the job without need of rest. Okay, so basically stamina is used in organization of the work and the rest schedule. Those who have the very strong and very good stamina, they can continue to do the heavy work for longer time, while those who don't have that strong and good stamina, they need the rest much earlier. Okay, so if you see a human being is supposed to have a stamina of applying the energy at the rate of 4 kilocalorie per minute. When a human being is doing the work where energy consumption is at the rate of 4 kilocalorie per minute or 280 watts, if this is the energy consumption related with the work, this is considered as accepted energy consumption, wherein if this is the level of the energy consumption, then there is no need of the rest and human being can continue to work for longer time, except when the breaks for the personal need or the break after 4 hours is to be given. Okay, so an energy expenditure of 4 kilocalorie is the maximum that a man is capable of to deliver for longer time without need of rest. Okay, so this is one thing. Human stamina is about that ability to do the energy expenditure to give the energy at the rate of 4 kilocalorie per minute without need of rest. Okay, this is the accepted thing. But those works and activities which need much more energy than this 4 kilocalorie per minute or 280 watts, then in those cases the energy reserves available with the human being will be used when the work is done. So these energy reserves will gradually be depleting during the work, and eventually these will be consumed. And whenever these are consumed completely, one may faint, and therefore there will be a need of a break. So all those works and activities where energy consumption requirement is more than energy requirement for a work is more than 4 kilocalorie per minute, there will definitely be need of rest. So in those cases we must consider after how long time the rest can be given and what will be the duration of the rest. This will so there are 2-3 methods based on which work and rest schedules are determined. So what happens whenever these energy reserves are used, in the body certain undesirable chemicals are produced, which also includes the water and some other chemicals, those which will be causing the fatigue. These need to be removed from the blood, and that is why the rest need to be given. Okay, so in order to overcome the fatigue related with the work, and so that the body can recover from the fatigue, undesirable chemicals from the blood can be removed, the rest must be given in all those cases where energy requirement for work is greater than 4 kilocalorie. Okay, so just for example, energy reserve is of 20 kilocalorie, just for example. Okay, accepted energy consumption is 4 kilocalorie. If the work for a given work energy consumption requirement is 5 kilocalorie per minute, then extra energy consumption is taking place 1 kilocalorie per minute. Okay, 1 kilocalorie per minute is the extra energy consumption for which energy reserves will be used. So energy reserves will be using with the human being at the rate of 1 kilocalorie per minute. If it is assumed that there is a energy reserve of 20 kilocalorie within a human body, then the worker needs a rest of the 20 minutes. This is simple. And if the work energy consumption is 6 kilocalorie, 2 kilocalorie per minute energy consumption extra is taking place, then worker has to be given the rest after 10 minutes. Okay, so the different jobs, different activities need the different energy consumption. Just for example, the body, when it is at rest and someone is taking rest on the bed, energy consumption is minimum, maybe say 0.8 kilocalorie or so. When someone is sitting, energy consumption is little more. When someone is standing, energy consumption is further more. When someone is walking, it is further more. When someone is doing very normal work, energy consumption is a little more. So like that. So starting from like say zero point 0.5, 0.8, 1, 1.2, 1.5. So energy consumption at the different rates for different activities. I will be showing for different activities how energy consumption rate will be changing. Okay, so as long as the energy consumption during the job or during a particular activity is less than 4 kilocalorie, this is indicating the stamina of the human being. As long as it is less than 4 kilocalorie, there is no need of the rest, and one can continue to deliver, continue to do the work without need of the rest. Okay, and as soon as the energy consumption increases more than 4 kilocalorie, the energy reserves from the body will be used, and in that case we need to give the rest. And how long this rest will be given, that will depend upon after how long time the body attains the rest level body parameters. So how that is measured, like the pulse rate, oxygen level, and like that, about also heartbeat rate. So those things I'll be talking in the next lecture. So although I could not cover the all aspects related to the ergonomics, I just talked about the anthropometry and the physiology. About the physiology, I have to talk about the effect of the working conditions and why it is important to consider the working conditions. Then there is a psychology, then there is an engineering system, like the man-machine systems or the mechanical systems. So about these two we'll be talking in the next lecture. I just started the ergonomic portion today. Okay, so that's all from my side.